Oh, you are new? How many? When did you start? Couple of months ago. So last few days. It was a hackathon, right? So what is the idea of Bitcoin? So think about your account. You have bank account? Have you ever seen your money in your bank account? No. So in the capitalism, so first when we start the capital, so we are living in the capitalism, right? It's not sharing everything. So anyway, so our economy is based on the capitalism, which means so our labor is a money long time ago, or the goods. If so, first start from the labor. So if we work hard, like the seed and the crop, everything. So you have the rice or the apple. So that is the capital, right? So who own that? Like some few people, or sometimes the king. Right? So like that. So because of that, at the time, we need something that is usually the man, human being. There's something that can provide the labor, like the slavery. So we need the slavery. So but after industrial revolution, it is changing. So long time ago, our effort to the energy will be the money like that. But after the industrial revolution, what happened? So no longer we still need such the agriculture, the industry, but mostly manufacturing so far. So which means if you have the machine, okay, then you will be the king or something like that. So which means we need still labor. So even the less than the minimum labor, like the few cents per second, the higher the person, the usually poor, the class, then the work for the company, and sometimes 20 hours work a day to learn to operate the machine. Then think about the nowadays. I introduced the industrial revolution. Okay, so sometimes it's called the fourth industrial revolution, which is based on what? Digital. So it's no longer for example, which one is the core currency in the worldwide? Core currency means if you have that currency money, it will be recognized by the order. It can be used for the trade. So US dollar. Okay. So US dollar actually starts from the what? How do you believe that this is real money? Okay. Then what is the value of that $100 bill? How do you guarantee? It's based on gold. Okay. It's a gold based. So which means somebody keep the FRB, they keep the gold when they print the money. But it's no longer. Why? The gold is limited. You cannot mine more and more. But we need more money, and people would like to make the bigger money and bigger. So if you print only based on gold, it's limited. So it's a given already. It's no longer based on the gold, which means people trust this money. It's valuable like the 100 and something like that. Also, it's a digital age. So even though I work for the UB, I got the money salary, but I never see my money. We trust that. Then sometimes we can invest. Such an investment is so nowadays capital is no longer the human labor. It's no longer the produce good. It's based on the money. It's a finance, the financial capital, which means the money make the money. But that money is based on what? Actually, we don't know. It's the same thing. So for the Bitcoin, sometimes it was happened before the Bitcoin actually. So like the people invest a lot for the tulip. You know the tulip flower, okay? Is it really because of the tulip is valuable? Somebody likes it, but not every and all the people need the tulip flower. But some of the people try to invest the money to the tulip. If a produce, whether it's fine, and then make the more money and that. Not because of the value of that, but the people need. People means some of the investor, not like the us, but the only few. Those who own the money, they try to make that's the kind of it's natural, the characteristic. Those who own the money or the money would like to make it bigger itself. Okay? Otherwise they cannot survive. That's the nature. It's the nature. So they need to invest the money to the first time the oil or the something the natural resource we can see it's a visible. Then that makes sense. Sometimes oil is needed, but it too much depend on, and also it's a limited also resource. So they try to see some even the unrealistic thing like the tulip. Then nowadays that's from the digital. So, but if that is easy to copy, so they don't want to. Not many people believe, but the Bitcoin use something very hard to decode, something code, and then make it the trustable. It's a trusted, then would like to invest. It's like the almost gambling, digital age gambling. But that's true. Any investment nowadays is gambling. Really, no matter where you invest money, that's the reason I'm not doing investment a lot. So I envy some of my friends who got the money or such a thing, but so I still believe the human labor is the first resource of the goods. Okay, like for me, it's the teaching. So if I make the money to invest, whether the midterm is good or not, I don't think that's the real my objective of the teaching. Even though I'm pursuing to make the money for my teaching, but that should be based on the human labor, which means the teaching at the class. But you should be careful to invest the money. But I'm a person who believes that trend will not be changed. That's the right direction. Not right direction, that's the direction which cannot be reversible, which means it will not be go back. It can be Bitcoin, but it can be different name of that. I think already Bitcoin is separate the branch. Some of them will be survived, and then few of them will be survived. The other will be gone. Gone means you lose everything. So be careful. So to do that, okay. Also, to think about who lead such a thing. Not is the general, the direction is based on those who have the money already. They need, it's a kind of nature of the money. They need to make it bigger. So it's moved to the data to make the money. So I think it will be the direction, but not sure whether Bitcoin or the current one will be forever. So they will maybe quickly change it to the similar thing. The Bitcoin is already split into the Bitcoin Cash or the Bitcoin, the original Bitcoin. But as a computer science student, at least you do better read at least Wikipedia. What is a Bitcoin? Okay, and then as a common sense. Even though you do not invest the money, but who knows? You develop the machine. The Bitcoin is simple. If you run the algorithm because it's something is fixed, then the split until you get the code. So which means you probably heard about the Bitcoin mining. Yeah. You run the computer and until you got the problem. Who make the actually really money?
The one who has most computing.
Yes, yes, the computer research. So think about such a way as a computer science student. Okay, then today we are going to continue finalize the one more thing I'd like to mention before we start the lecture. The last weekend I attended one conference, interesting conference, to talk about something the computer science research as well as the networking. I realized that one of the main trend of the computer science research is the AI, as you can expect, and the machine learning, and specifically deep learning. Okay. We talk about a little bit what is the post-neural network, post-deep learning, which means after deep learning, what will be happen, and what is the next the area or topic after currently the deep learning has been and is being developed and proposed a lot. It's not finalized yet, but certain time it will be reasonably done. Then what will be the after that? So I also thought about such the topic and not doing the real thing yet, the research yet, but after the deep learning era, the AI era, the next, not it's overall AI, but after deep learning, it will be like what is the output of the deep learning? It's a classification, it's a decision, whether this is a cat or a dog, whether this is the person or what they are doing. Those classification is a very basic knowledge of the people. When you are 5 to 6 years old, you can do such a thing. But after actually deep learning is not the general solution of the intelligence. So it's just a part of it. But the next level of the such AI will be when we have such a knowledge, like you have the knowledge, ability to classify this is dog, this is a cat, then what will be the next one? Manage such a knowledge. We are not the human brain. You are not doing the training every time, the running, the processing to classify this is dog, this is a cat. At certain time, your mom will teach. Whether you learn that this is a cat, this is not, this is the dog, but at certain time you use such a knowledge, or sometimes enhance your knowledge, like your interest for the classification of the animal will be used for something your major. Okay, it's more the high level. It's very hard to say the certain level, but high level, such using the knowledge, which is called the knowledge management. Who is in charge? Who can do such a knowledge management? After you got the result of the machine learning, it's a database. So database. Actually, we didn't have such the machine learning before. Instead, we apply what? For example, ER modeling, conceptual modeling. Instead of processing, we just collect the student information, name, ID, address only, because it's my ability as a database. Then when we have such a very well, it's actually it's not flexible, it's a very strict knowledge, predefined. So this is a student, the entity, student thing, and name, ID, address only. Then collect only such information. Then query that. That's the not level of the knowledge management. That's the very low level of the managing the data. Then after such a machine learning, when we have such a knowledge to classify the cat and dog, for example, and predict the weather, okay, then what will be the next? So we need to manage such a knowledge to get the really intelligence. Then who is in charge of? I think the database should lead such a thing, because database they deal with the structure to manage the data information or data. Then eventually it will be the knowledge. So maybe the few years later, the syllabus of this class I think the NoSQL database may be kind of in between. It's a kind of a transition of such a thing. But I didn't introduce in the classroom. It's about the textbook slightly mentioned about such a knowledge management, which is called ontology. So ontology was discussed, has been. So if you are interested in such a knowledge management, you can see the ontology. So ontology is one of, it's not new one. We have been discussing a lot 20 years ago to manage the knowledge, but actually we expect the ontology replace the database in a system, but which is not. Instead, XML replace the ontology part because using XML we can define certain concept. It's more flexible than the database. So XML has been used a lot. It's limited, but still XML is limited. Still used, but it's to manage the flexibility, to manage the knowledge. So we talked about last weekend whether ontology can replace the position of the XML and DBMS in terms of the knowledge management. Please think about such a thing while you are studying the database. But go back to our topic, that is the normalization. For the quick summary of the normalization, so we have an unnormalization form. Unnormalization form means, do you remember when I start the database design class, this one? Information. Information is everything. So same thing. The unnormalization form is the everything together. Where some of the data are redundant and the conflict doesn't matter. Just put together. It's one big jar of the information put together. Then our goal of the database design is what? Remove redundancy. Okay. Eventually, if we remove the redundancy or the duplicate data, so it will be easy to manage and very fast to search the data. So we start from the unnormalization form. Then the first normalization form is for what? We take a look at each attribute. Each attribute is the non-composite, non-nested, and non-multivalued. Because if you allow this one, it will be redundant information. So focusing on in other words, the first normal form is atomic, the variable for each attribute. Atomic attribute, atomic variable for each. Then second normal form is we focus on the key. What is the key in the normalization form? It can be primary key and candidate key both. Okay. Some of the key are A, B, C, composite primary key. So any attribute, other attribute should depend on whole key plus candidate key, whole key dependency. If you allow partial dependency, which means partial means it's a different meaning. At this time, this arrow is dependency means functional dependency. Functional dependency means X determine Y. X is what? Set of attribute. Y is the also attribute. So ABC determine D. At this time, X ABC is called prime attribute. So prime attribute determine non-prime attribute. That is the dependency. That is kind of a meaning. When we talk about the meaning, how many meaning for each table? One meaning. Everybody know, informal way. So formal way, mathematically, we can define such a meaning. What? Dependency, using functional dependency. So first we need to take a look at the attribute, then decide which is the prime attribute, which is non-prime attribute. Non-prime attribute determined by whole the prime attribute, not partial dependency. So whole key dependency. Then another level, the string. It's getting stronger, which means less redundant. So from outside to inside. Third normal form is, so we have seen the X determine 1. Number of attribute determine non-prime attribute. Non-prime sometime attribute determine another non-prime attribute. So this is called transition. Okay. So in this case, so if we allow this one, even though this is okay in terms of a whole key dependency, but this is a different meaning. So we remove this one. Okay. So no transition. So that is the third normal form. Good news. Most of people, even though we do not know anything about the normalization form, anyone can grouping, classify up to third normal form. Think about your room. If you classify, if you clean up your room, you don't want to mess up all the stuff. Some of them are doing, but most of them. So you collect all the material for the database and the operating system, network, and so on. That's the idea of the third normal form. Okay? So third normal. That is the reason, even though you are not taking the database, many people can do simple database design automatically, intuitively. There's another one, BCNF. BCNF is the most called normalization form. It's a strict version of the third normal. Sometimes X determine Y. Then Y determine, for example, X is A and B. And this is a C attribute. And this is A, which means C determine A. However, A is what? Originally start of the C. So this is a prime attribute. So in terms of third normal form, this is not in third normal form. Why? Because it's not transition. It's going back. So in this case, it's a third normal form. In terms of third normal form, it's okay. However, the Gaussian code realized later, even if this one is the prime attribute going back, this one is also slightly different meaning. So we need to separate this one, segmentation. So BCNF is the strict version of the third normal form. Plus, there is the fourth normal form, fifth normal form, special case of the normal form which we are not going to discuss. Very rarely happen, but sometimes you need to take care. So in case you encounter something weird name of the normalization form, you can take a look at textbook, and you are able to realize. So for example, multi-valued one will be the discuss also here, but we will not cover this specialized normalization form here. Instead, up to the BCNF. Most of case in the real life, the database design, BCNF is enough. Then, how can we make the normalization form from the unnormalization form to the BCNF? The only solution is you can segment by the meaning. So using, actually meaning is the functional dependency. Okay, so this is the example of the real example. As I said, normalization can be used for the database design two ways. One is you can fully use only the normalization form for database design. Okay, this is the case. Another way of using the normalization form is once you follow the conceptual design and the relational model and then the finally database design, you can test, you can judge whether my database design is good for the good based on this normalization form. It's called the goodness measure. So you can use the normalization form as a goodness measure. So that is the second way, is the most popular in real life projects. So for example, your project manager asks check with the BCNF, the database design, whether it's satisfied with the BCNF or not. In case something happens, normalize or segment. So, but this is one example of the first use case of the normalization form. So for example, your customer bring the invoice. It's a real example. Then ask, I'd like to manage this is animal hospital. Here type animal hospital, the database. So you need to database design. So this time, is this the only the invoice? Probably a number of, this is just one example. So you need to identify which one will be managed. Okay, what information will be managed. For example, INV or IC, do I have to manage this one? No, it's a printed. will not be changed. This is an invoice database. It will be used for name of database, not the table, not the variable. What about the address? How many address? Only one address. In case you have the 100 branches, then it will be different story. But in this case, it's a printed. Just one, so you don't have to manage as a data. However, invoice number, we need. Date, we need. And this is a customer information. We need to manage. And this is the procedure and amount. For example, what about the tax? Tax rate will not be changed. So it's just one value. So, however, if the hospital is all around the world, all different location, at the time you need to manage. But in this case, let's say that this is only one fixed the value. We don't have to. What about the amount owing? You can calculate the divide. So depending on your decision, it can be divide attribute or you don't have to manage. So based on that, this is an unnormalization form, which means collect all the information, like the invoice number, date, customer name, customer address. What does that mean? The parentheses. If you take a look at this example, how many procedures? So one customer bring the couple of packs. So you issue the invoice, one invoice, which means a number of procedures. So this is representing pet per the procedure per name. It's the number of, okay, like the nested one. So this is a normalization form. We don't have to worry about anything. This is not the database. It's like the information collected. And at this time, we can use the invoice number for the key to identify. If you cannot find, it's okay. So this is a normalization form. It's not the database. It's the starting of the normalization. So first step, is it the first normalization or not? No, because of this one, right? This is a multi-valued or this is a nested. So we need to take out atomic. Okay. So first normalization form is we can start from the atomic. So we can take out the nested one. That is name can be different. However, as I mentioned, so I cannot teach the naming rule. But the suggestion is as long as other people identify the meaning of your table or the attribute, it's okay. However, it is really true. So if you join the usually small project or the small company database, sometimes their name is T1, T2, T3, C1, C2, C3 for the column name, PK1, PK2 primary key. Really, that happens. So, but in the normalization reasonably. So if you answer like in your final exam, like the I1, I2, you may not get the full credit. So at least I should be able to identify the meaning of that. So in this case, like this one, invoice number. Why is the invoice number should be connected? The pet ID, because each pet and each invoice. Okay. Then in this case, we add a surrogate key instead of pet name, pet ID, just in case. So avoid the duplication of the pet name. So this is the first normalization form. Somebody may be argue what about the customer address? It can be composite, like the tree. The address consists of blah blah blah. If your application need to access separately, you can do the normalization here. Always you need to consider application analysis. But if your application access address all together, okay? Always this one is the address one attribute. You don't have to, okay? It depends on. In this case, we will use just the customer address. What about the second normal form? Second normal form is whole key dependency. Means this one is automatically whole key dependency, right? It's a single prime attribute. You cannot make it partial. It's a whole key dependency always. This may be What about this one? Invoice number, pet ID, determine pet name. However, for example, in this case, the pet name is not depending on the invoice number, right? Pet information is based on the pet ID. So to address that one, we can take out the pet information. Okay, this is a partial dependency. I know there is no pet ID here. Since we add the pet ID for our convenience, so in case the pet ID is not, you should include the pet name as the invoice number and so on. But at that time, you should have the assumption like each owner has the different name of the pet, something like that. So this is but since we add the pet ID determine pet name is a partial dependency. So then the other invoice number plus pet ID determine procedure and amount and so on. So this is the second normal form. What about the third normal form? Third normal form is the transition. Can you find the transition? Procedure determine amount, right? Each procedure has a specific amount of the money. So procedure determine amount, which means invoice number plus pet ID determine the procedure determine amount. So this is a transitive. So we can take out, make the segmentation. Oh, another one is customer name, determine customer address. Okay, so this is also transition. So invoice number, customer number, determine this time we separate. For better. For example, while you are doing the second normal form, you realize that this is the application need this information. You can separate, or it can be just customer street. It doesn't matter. And pet ID determine pet name. But this time, procedure determine amount is not separated. So which means you decide this is not the transitive or because of denormalization. So we don't have to, instead of for example, most of the time procedure and amount are used together. So we don't have to separate. So assumption is like the procedure and amount is denormalized. Okay. And the final, that is the third normal form. Okay, this is a little bit more complicated. So we will see it up to this one. So we have the unnormalization form. Ship name, ship type, the voyage ID, and cargo, port, and date. Then we identify many of the time. So I will give the functional dependency. The reason is that depending on your assumption, it can be variety of the different functional dependency unless I provide the data. So sometimes I can provide the data. Sometimes this is a more practical example. In your real life project, you will see a lot of data. So you need to decide first, like the functional dependency based on the data. Okay. Otherwise, the functional dependency will be given like this one, which means ship name determine ship type, and the voyage ID determine ship name and the cargo, and the ship name and date determine the voyage ID and port, and so on. So we will follow the direction.